So let's say that we are in an eigenstate of energy. We have a particle that is forced to live between x equals 0 and x equals L, and it's in an eigenstate of energy. So psi of x and t is root 2 over L. Let's make it the n equals 3. So we have sine of 3 pi x over L e to the minus I e 3 t over h bar. That's the wave function. And now let's let's predict where the particle will be found upon measurement of its position. So we have some device that measures the position of the particle, and we make a measurement, but we want the theory to predict where it will be found. And the answer is the theory doesn't make a prediction of where the particle will be found. Remember that if we have many systems that are in this state, we can then predict what the distribution of measurements will give us. So we can predict this quantity, the average of all of these different measurements. They will tend to the theoretical value that you get when you calculate the expectation value of x. But there's no version of quantum theory that tells us clearly what outcome to expect in one experiment. This is completely different from other physical theories. But what about predicting where the particle will not be found? Right, so we take psi 3. Well, that's what we have. We have psi 3, but we want the probability density, which is psi of x and t modulo squared. That's just psi 3 of x squared. And that quantity goes to 0 at certain locations. So P equals 0 at x equals 0. So first let's write this out. Right, this gives us root 2 over L sine squared of 3 pi x over L. So at x equals 0, the probability density is 0. It's also 0 at x equals L over 3. Right, we put L over 3 in here. We get pi, sine of pi is 0. And at x equals, of course, L. Right, 0 and L, it's obvious that the particle will not be found there. Those are the sort of the extremes of the region where it can live. So it can't be found here and here because the function has to go to 0 there. And so does the probability density. But in this state, there's also a location right here, a third of the way to the other wall, the other boundary, where the particle can never be found. And that's clearly a I'm sorry, it's so this is true, but we also have, let's put it here, an x equals 2L over 3, because at x equals 2L over 3, we get 2 pi, and the sine of 2 pi is 0. So these are actually, there are actually two positions here. Could have argued from symmetry that there had to be a location there as well, given the one that we found there. So there are two interesting locations where the particle can never be found.